So everything this year is on this midterm. And yes, on our final, Angus, that we take at the end of this semester, it will have everything from last semester and from this semester on it. It will be a full year-long cumulative test. All right. So, yes, that is part of an honors class. Things are a little more difficult, but I know you guys can do it. You got to put that effort in. This isn't the type of class where you can just come, show up, and take a quiz, or you can just show up to class and then leave and then be done, and then maybe just do your homework and be done. This is when you do the work, you do the homework, you do the class, and then you ask yourself honestly, and you have to be honest with yourself, do I know this? Do I understand this? If the answer is no, you need to make sure you understand this and figure out a way. I'm trying to get you guys trained here for college. In college, oftentimes I had professors who never gave me any homework. No actual work outside of class. They just stand on the board, they teach. And when they're done teaching, you go away, you come take your test later. You find your own homework. You find your own way to study. And if you don't study, even if you're some of the smartest kids in the class, right? Even if you're normally, and I was this kid, even if you can normally throughout high school show up to the quiz and be like, no problem, I'll do great. Even those kids would have to study for hours and hours and hours. I'm trying to push you guys because I know some of you are that kid who thinks I don't need to study. Yeah, well, you're gonna have to study. Okay, that's gonna change. All right. I didn't write the numbers out here up top. So let me write it as I call your name. Ricky.
Do you love me?
Kyle Huang. Jerry. Welcome. Hannah. Angus. Sherry. Josh. Serena. Leo. Ryan. Jake. Tom. Alice. All right. Take a moment, look at your points, what you got wrong. Tom, you may not mind if I call you out, single you out a little bit about your test. Okay. So, how did you do that? How did you do it? Tell us, Tom. So Tom, in the whole class, is the only one I'm really happy with right now.
All?
Tom did really well. So, Tom, have you learned this outside of class? Did you just listen and learn it from me? Really? No extra study tips for them?
No homework.
Really? Okay, well, never mind. Tom's just a genius. Sorry. All right. I thought maybe you had a secret you knew about this.
Ask me out.
Yeah, maybe ask Angus. He's
Me out.
So, but overall, our average is 49%.
Oh my god.
Yeah. That's, I think, about our worst one yet.
19,
So-
29, 39.
But I know this quiz was possible. I know because I can do this quiz. And a lot of it, and the weird thing I saw a lot of you students do, and maybe you guys just didn't bring your calculators, which would be horrific. But I saw a lot of people write the problem then just like leave it. And not type it into a calculator and hit enter.
Correct.
So maybe it's that we don't feel comfortable using our calculators. Because most of these questions, you had to plug it into your calculator. You're not doing it by hand. And is that the problem? Have I just not been showing calculators enough? So maybe that's it. Do I just need to do a calculator day and go through all these with calculator? Is that the problem?
I think that would be necessary.
Maybe? Okay. Because I'm trying to figure out where the gap is. I was talking to other teachers, and I do realize now that I guess exponential functions maybe are not an easy thing to understand because we don't see exponential in life too often. But yes, we do. We really do all the time. You just can't physically see it with your eyes as well, right? You have to look over long-term trends. With the coronavirus, that is a very real, very vivid example of the power of exponential growth, right? Sorry about that. But on top of that, like, oh, that's annoying. Okay, but like anytime you put money in a bank, that's exponential growth. It's long term, but if you calculate how much money you're making from a long time, that's exponential growth. You look at the population of the humans over a long time, that's exponential growth. So there's a lot of good applications for it, but maybe it's just something we're not used to as much. In 8th grade, I taught it from the perspective of geometric sequences. Right, times 2 times 2 times 2. That's what happens at one time. Right. Alright, any problems you guys want me to show?
So number 2, number 1, B, and C.
Number 16.
Okay, hold on. I'll take votes. 1B,
Can we go to B?
1B, 6,
1, B, and C.
1, A, B, C, to all of 1. Okay. Number 5,
Number 4, A, B, C.
4.
3, D, and E.
You just want the whole test.
So I got 4.
You get to choose 1. Which one do you want? 4? Okay. Alright. 8.
Hey, wait a minute.
Hannah, didn't you choose 4? You chose 5. Do you want to change it to 9?
Who was the
Alright.
number?
Hold on. I'll try to do as many of these as I can. Alright. I'll try to go through this as fast as I can. I want to get through a lesson today, though. Yes. Alright. I'll try to go through this as fast as I can. Everybody, here's the answers. I'm going to go through this quickly. Here's all the answers on the board. Here's my answer sheet. Okay? They're not very pretty. I haven't made them red. I'll try to make them red while we go. Okay? So growth, decay, growth. Hey, even if you weren't able to you didn't remember the exact rules, you couldn't simplify it, look at this graphic. Does it go up? Does it go down? Type this into your calculator, graph it, and say up or down. Right? So those should have been 3 free points. Next one. Oh, here's the 4th free point, number 2. Decay. What is the rate of decay? Some students wrote 85%. No. How much does it go down by every time I multiply by t? By 15%. It goes down by 80, it becomes 85% of what it was. If I take 100 and I multiply by 0.85, I get 85. 85 is 15% less than 100. Does that make sense? That is the rate of decay. Remember the formula is y equals a times 1 minus r to the t. So 1 minus
What?
for decay functions. Yeah. When will the population be about 2,000? What I wanted you to do, guys, again, graph this and see where it hits that. Look at your graph that line and graph the line y equals 20,000 and see where they cross, intersect. right? Then that would be about at 4. It was like 4.3. So I also took 2010 if you kind of thought that way.
Okay.
Alright? 3. The domain, oh, this is a freebie. Negative infinity, infinity. Free point right there. The range, -4 to infinity. The -4 is a translation down 4. The rest doesn't change the asymptote. Again, if you graph it, these using your calculator, all this is pretty easy to see. C, as x goes to infinity, fx goes to -4. Again, you graph it and look at the picture. It's pretty easy to see. And the asymptote, that is y equals -4. I quickly wrote that
How
out.
about 0, -4?
No. 0, -4 is not a line. Asymptote is a line. Y equals -4 is a line. I taught lines in 7th grade. So you should know those by now. Okay? 4. What I was looking for was this, and this isn't a very good one, but here's how it looks. The limit as x approaches infinity of 1 plus 1 over x to the x. I did not require this part. All I required was you to write this, because I talked about this. But the full formal way to write it is as this approaches infinity, as x gets bigger and bigger and bigger. But I don't expect you to have limits covered yet. Alright? B is Euler.
How about Elizabeth?
I don't know what you just said. What?
Elizabeth.
Elizabeth.
Yes.
No, it was not Elizabeth.
Okay.
Okay. It is irrational. We covered this in chapter 0, I believe.
Well, I think.
Why can't you move the number y, write the number y as a ratio of 2 integers? Because it's irrational. That's what the definition is.
So irrational is
Cannot write it as a definition.
as a
ratio.
whole number.
So it's like
Like 2 over 3. A ratio of 2 numbers. There's no fraction that is e. Yes.
Well, why
Whole not every
why
real
we
whole
can
number.
say because it is not a real
Irrational numbers are real numbers.
So this isn't right.
Go back to your chapter 0. We have here are all real numbers. Well, let me give myself more space. Real, imaginary. Right? This is the complex numbers. Inside of real, there are the rational numbers. And outside in here is the irrational numbers. Irrational numbers are real. So E is a real number. E is a real number. So is pi. They are real numbers.
How about
Yes.
What if you write because it can't be divided properly? That sounds.
Yeah, that's like
It's actually-
circular.
it's actually
Why?
right.
Yeah, no, but why can't it be divided? Because it can't be divided. You see the problem? Why can't you go outside? Because you're not allowed to go outside. It's circular.
How about-
It's not actually saying why. Yeah.
it will not ever be a whole number?
That's again not true.
Why?
I mean, yes, it's not true, but that's not why. E is not a whole number. It's 2.718. Right? Blah 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 blah. But it will never be a whole number, just because this is not a whole number, but it can be expressed as a fraction.
Oh.
Right? Even 0.666666 with a bar is never a whole number, but it can be written as a fraction.
Oh.
Yeah. All right. 5. You should have gotten 9,200,000 in it. Let me make that nice and easy for you guys to read. I write these quickly as I go through them. So it just that you're just doubling it 7 times. I thought this was a freebie as well. You don't even need much. It doubles every 7 years, every 10 years, and there's 70 years. It means it's going to double 7 times. So just times 2 7 times would be the simplest way to do it. Or just multiply it by 2 to the 7th. Right? Alright? On the back. So most of you guys actually did okay on the front. But on the back, it's where the scores just like went to 0 for some of you, or like went really low. Back. Here's what you should have written. 8 million times 1 plus 0.85 to the t. If you write 1.085, that's fine. But writing 0.085 to the t is not okay. You gotta multiply by a number bigger than 1 to make it bigger, right? For exponential growth. If it's less than 1, it's gonna be a decay. Again, graph this and look at it. If you graph what you write here, it should be going up. It should be an exponential growth function.
So if it is a decay function, we need to what minus?
So if I have something like this, if I have y equals a times b to the x, if this here is greater than 1, it will be growth. We're going to assume that x is positive. Oh, no, it doesn't matter. X is a variable. Okay, sorry. And if b is between 0 and between 0 and 1, right? Then it'll be decay. In 8th grade, I referred to this as the common ratio. If you remember the common ratio, the number I multiply by over and over and over. If I take 8 million and I multiply by a half, 4 million, then multiply by a half again, boom. That's what I'm doing here. Every time x goes up by 1, right? If I make b 2 and I double, it's going to get bigger. You guys know this. Multiply by a fraction, it gets smaller. Multiply by a bigger number than 1, it gets bigger. Alright? B, that would be, what is the value of 2018? You'd have t equals 10, so you should get 18,090,000. I had a few people who would like write it incorrectly and then like not hit enter correctly on their calculator or something. I was confused how I got multiple answers from that. And let me know if I made a calculator error, but I got multiple different answers from people on that, even though they wrote the same formula. When will it be about 20 million? Again, graph what you wrote in A, and then see when it hits 20 million.
Why is not 2020?
It's
Why is not 2020?
oh, did you write 2020?
Yeah.
Okay. Did you really?
I wrote 2020 in here.
Okay. I'm not sure. I think it's like probably.
I turned that 2020
Yeah,
is
I'm
over.
not exactly sure what the fractions are. I could double check, but I'll give it to you.
Yes.
Because clearly you understood what you were doing in that area.
You know, I.
Anybody else write 2020?
You know, I thought for 2019 is.
Yeah, it depends.
1.1.
These ones are ambiguous depending on exactly what month you think it started in.
So I think, can we correct?
Okay. Any others? I corrected yours. On my grade book. Do you want me to correct it on paper?
Yes.
Here?
Yeah, that's their trouble.
I think can we take?
You can all do retakes, yes. D, you should have gotten 28,600,000 to 20.
How to do this?
All right. Here is exactly what I did when I did this one. All right. Well, so your house starts at, let's go to A again. Take a look at A here. So the house is at 8 million to start. Then is at 1.085, 8% for 10 years, right? That is the answer you got in B. Now, it says starting at 2021, we expect the rate of growth to change. So that would be 3 more years, right? Here. Good? This is what the value would be on 2021. Make sense? Now, starting at this value, it's going to increase at 5% per year. And we ought to figure out for 9 more years. So take this and multiply by 1.05 to the 9. And there you go. You don't even need to really, you just need to plug into your calculator once. Now you could figure out what it was in 2021, write that number down, and then put this here. But why? Why when I can just say, oh, this times that? Right, it's the same. It's this is right here. This is value in 2021. And then, so 13 years, 9 more years here.
Yes,
Boom. And I just, when I did this problem,
So I'm correct.
is that right or wrong? Did I do
Yes,
it correctly or wrong?
No, you're wrong.
Go away, I'm
Cheat
19.5.
Let me see. Cheat sheet.
8,
2, 3,
18.5.
4, 5, 6.
1.
Yes,
35.
5, 8, 4, 1. And
Oh no, did I make a mistake?
oh.
I also plan to change this problem, so
Okay.
I changed it to 2018 for future use. Because I was like, mean problem.
What the?
Oh, yeah, that's right. Okay, so you've got 3.8 million, 35 million. What'd you get? Let me see your answer.
Hen nine.
Hold on. So 35 million, right?
3, 5, 8, 1, 0.
You two got that? Did anybody get 35.8 million?
No, hen nine.
More or less. Okay, 2 points? Nice.
I have no time.
Tom and you want me to write down your paper or are you good?
Sure.
Okay. Any other questions? Alright, good? Thank you for pointing that out, boys. Sorry. Alright. Also, when doing these guys, I got people who like here would say like the value of the house went down. If it's growing for 10 years, it's gonna be bigger. So do that quick like reality check. Is this number supposed to be bigger or smaller? Alright. On the simplifying section, again, I thought these were easy. Maybe it's just me. E to the 8 over times x and 2x squared e times the 6th root of x squared e to the 6th, x squared e squared. Until you students start getting this consistently, I'm gonna just continue putting this on test. Yeah, I'm gonna just continue hammering this because you all need to be able to do basic algebra like this. As far as I'm concerned right now, this is basic algebra for you. Alright? We should be able to reduce radicals. We should be able to reduce a fraction here. Right? As far as I'm concerned, this is reducing a radical. This is reducing a fraction. You all should be really good at this by now. And the problems will get trickier and get more difficult, and I will continue to ask you these. So don't let these two go. Expect them on your quiz, on your midterm, because you'll have something very similar to this on your midterm. I think. I already made your midterm, so I'm not exactly sure. Alright. 8. 3.5. A lot of you guys got 3.5. I was happy to see that. But the second one, almost nobody got the second one. They answered 24.8 or 25.
It's not 4.
Yeah. So many people put 4.
Oh, yes.
Guys, okay, look. We have 10 milligrams after 5 days. We want to know how much we started with. If it's going away after 10 days, we had 10. How many did we have 5 days before it? We're going to have more. It's radioactive decay. It's going down, right? So after 5 days, it went down to 10. It had to be bigger than 10 to start. Again, double check with reality every once in a while. Make sure your answer makes sense. And that really applies to the last question. All right? The last question here. If you knew these formulas, you can just basically plug it into your calculator, you're done. Okay? So here's your 3 answers. I'll try to make them easy to view as best I can. Okay, so 68,600. Rounding's okay, but on these, I want to see a few decimals so I see that you can tell the difference between them. Right? Don't just write 70,000, 70,000, 70,000. Boring. Right? 68,700, 68,900, 68,200 would be the most I'd want you to read around to. Really. Right? But err on the side of more than less. For now. Science classes will be more picky. But again, everybody, all I changed here was how we calculated the interest, right? How often we compounded. So your 3 answers should be pretty close to each other. And you put the money in a bank, and the bank's giving you money, right? You better have more than 25,000. So this number better be bigger than 25,000, but it shouldn't be like 25 million, right? The money doesn't just poof into magic. But after, 13 years, doubling it at 7% is fair, right? There, but they also should be all pretty close. They shouldn't be that far apart. All right, there's the answers to the test. Good? Yes. Sadly, okay. So students, at this point, it's a matter of how much do we want to focus on these next 3 sections?
Can we go next week first?
I think I kinda have to go on to these. Because this is for the quiz. Do you have a quick question? Yes. Did I add them up wrong?
I don't want my photo.
Come up, show me. So everybody, I'm sorry, I've gotta keep us going. So, and I don't want to just give you homework with no explanation. I thought about it, but no. Okay, I'll give you half a point. You're so close. I know, you can do it, bud. Okay, if you want to argue for more points, do it later from me. I don't have time in class for that. Okay, students, please take out your notebooks, open up to page 51. You do have homework today, and it is auto-posted already on Google, on the Google Classroom. I have scheduled posts that will post your homework as soon as class starts every day. So it just posted on the Google Classroom. But if you want to write it here, it is 6.3, numbers 17, 21, 29, 34, 39, 43, 45, 47. Maybe we need more homework, I'm thinking here. Alright, so there's your homework. It's also written on the Google Classroom. In addition, Khan Academy students, I have a video posted, okay? I have a video on there posted, as well as recordings of this class I posted on YouTube. Alright, so you got plenty of resources, plenty of things to do, alright? Digitalizing here. But let's go through the book. Woo, I'm gonna go fast. Fast. Number 1. You know that 2 squared is 4, and 2 to the third is 8. However, for what value of x does 2 to the x equal 6? Alright, so that's our question. How can we solve this problem? Seems like a simple problem, small numbers, but it's tricky. Mathematicians define this x value using a logarithm. Oh, that's an H and an N mixed together.
Using
Logarithm. Write x equals log base 2 of 6. Parentheses are optional. Alright, I put the parentheses by habit, but you don't have to put the parentheses there. Therefore, therefore logarithm is therefore an inverse function. Alright? So log is the inverse of exponential functions. They are opposite each other. Jake, you should be writing this down. Alright? So now let's do a quick definition of these. Does this make sense? Log is just undoing, raising it to an x power. Definition of logarithm with base b. Let b and y be positive real numbers with b not equaling 1. The logarithm of y with base b is defined as log base b of y equals x, if and only if b to the x equals y. So that's what this says here. If I have log base b of y equals x, this means the same thing as saying b to the x equals y. These are the same thing, just written a different way. Right? The expression.
No, what is the answer?
Oh, well, it depends what bx and y are. We're gonna get to how to.
Log by.
We're gonna get to how to solve these in a moment. Right? The expression log base b of y is read as, well, exactly how I've been saying it. Log base b of y, like that. The expression on the left is in this expression is in logarithmic form. And the expression here is exponential form. I didn't spell that right. It's called exponential. Exponential. So here's your exponential form. We know that one already. But we're introducing logarithmic form.
Okay,
We'll give you guys a second to catch up.
I know.
Good. Questions before I move on?
Yes, I know already.
Okay. So, number 3. Rewrite each expression rewrite each expression in exponential form and logarithmic form. Alright, so we have log base 2. Log base 2 of 16 equals 4. This would be the same as 2 to the 4 equals 16. Those things are the same. Log base 4 of 1 equals 0 is the same. The same 4 to the 0 equals 1. Can you guys fill in the rest of these by yourselves? 12 to the 1 equals 12. And 1/4 to the negative 1 equals 4. And similarly going the other way. It's just a matter of unwinding it. So all those things are saying the exact same thing, just written in a different way. On the second part, your answers would be, so 5 squared equals 25 is the same as log base 5 of 25 equals 2. And the rest of the answers are log base 10 of 1/10 equals negative 1. Log base 8 of 4 is 2/3. And log base 1/4 of 4 is negative 1. I do have to point out that while it is technically possible to have a fraction as your base here, it's rare. Typically when we do logarithms, we focus on 2 logs. log base 10, and log base e. Make sense? I think I already went over this a little bit with you guys, so I think this isn't 100%. Alright, 4. 2 special logarithm values that you should learn to recognize are the following. Log base b of 1 equals 0. 0 because
B 0 is 1.
because b to the 0 is 1, and log base b of b
Is 1.
equals 1 because again b to the 1 equals 1. Oh, b to the 1 equals b. Good. So these two are ones that you should quickly recognize. You should quickly just be like, okay, log base anything of 1 is 0.
Yes. Yes.
Yeah, why is Angus sitting there? Angus, aren't you still in 14 days of quarantine?
No.
Yeah. Can I put you in the quarantine?
No.
The corner team? Thank you. Please go sit in the corner team.
No lah.
He's corner team.
It's not okay.
No, Angus, move. Thank you. Okay.
In front of Tom.
Yes, in front of Tom. Good. Tom can sneeze on you. You cannot sneeze on him. That's the way basic forward works. All right. So, Tom, can you move your desk back a little bit so Angus can come over? Thank you. All right. So, 5. Evaluate the logarithms. Thank you. What is Kyle? What is log base 4 of 64? 3. Why? 4 to the 3rd power equals 64. Does it make sense how that works? Because 4 cubed is 64. Sherry, can you figure out log base 5 of 0.2? Give you a hint. I'll write it as 1/5. 1, not 1. Listen to him. -1. Tom, what's the next one? Tom? Oh, Sherry's now doing Tom's. All right. And Hannah? Log base 36 of 6? Very good. 1/2. So, because 36 to the 1/2 is 6. Does that make sense?
Why so hard?
No, it's not hard at all.
Yes.
All right? A lot of you guys are able to do that just by looking at it, right? Now, it's nice when the numbers are numbers that we already know. Nice, easy, positive, negative, or even fractions. But it starts getting harder. So 6, I'm going to finish 6, and I think that's about it. Okay, boys? Tom, I know you're doing fine, but you need to not distract them so that they can pass their test too. Oh, speaking of which, I look forward to seeing all but 3 of you in my class here soon. Or, I mean, if you got like 58 or something, then you might not have to retake that. But for all of you who got well below 60, come take your retakes. Okay.
Yes.
Common and net. Hey, whoa. Shh. Let me get back. I'm finishing this before I let you go. Yes.
Do you have the Algebra 2 books? Do you have extras?
Probably bottom 26, I think.
Okay.
Okay. Shh. Okay. Logarithm with base 10 is called the common. Hey, you can get it from the name common and natural. So it's called the common one.
Let's go
And
the office because I'm not.
It is denoted log base 10 of, or simply log. If I don't write any number, it's assumed to be log base 10. A logarithm with base e is called the natural. We can get it by the title. By the natural logarithm. It can be noted by log base e, but that's strange. It could be, but is usually designated by ln. If you look on your calculator, below, above e to the x is ln. And right to the right there is log. They're next to each other. Okay? So let's evaluate these quickly. Quick last ones. Log of 8 is, do this on your calculator, everybody. Okay? All of you. Cherry, type this in your calculator. Angus, type it in your calculator. I want to see all three of these written in your calculator with the answers. Where's your calculator? Wait, huh?
Log
Oh.
8. Oh,
Where is it? Once you show me your calculator with these on it, I will let you leave.
Mr. Mega.
Yes.
Here.
Mr. Vega.
Very good. You may go.
Can I go?
Like this.
That's not all three of them. That's only one of them.
Oh.
See, this is what English. Why do you have Chinese in here? Log of 8. Oh, did you just type the word log? Log. Full log. Very good. You may go.
Mr. Mega, here.
You may go.
Mr. Mega.
I don't see two of them.
Oh, this one I got.
Log base 2 of 26. You may go. Wait. Yeah, you may go.
How to don't type this?
Mr. Mega.
Log.
Type in 10.
10.
Yeah.
Oh, here.
Or if you leave it blank.
Yeah.
Okay.
Mr.
There
Mega.
you go.
Mr. Mega.
Yes.
Can I go?
No, where's yours?
I feel you.
Okay, you can go. You get it? You got one of them, where's the other two? That's a weird way to do log. This one here,